Inside your body, right this very second, there's this unbelievably complex defense system working 24/7. It's like a silent, invisible army that's constantly protecting you from all sorts of threats. So today, we're going to crack open the gates to this fortress and get a good look at how your immune system really works.
Just look at this. This isn't some sci-fi movie. That's a real immune cell, a warrior on a battlefield that's happening inside you. Every single second of every single day, cells just like this one are out there hunting, identifying, and destroying invaders just to keep you healthy. It's this constant, high-stakes fight for survival that, honestly, most of us never even notice.
And this quote, man, it just hits the nail on the head. The world is absolutely teeming with viruses, bacteria, and all sorts of other microbes that are all looking for a place to call home. And our bodies look like the perfect spot. The sheer number of threats out there is just staggering, which makes the fact that our immune system works as well as it does all the more incredible.
So how does the body actually defend itself? Well, let's stick with this idea of a fortress. And what's the first rule of any good fortress? You gotta have strong walls, right? Before any battle even starts on the inside, our body has this amazing first line of defense designed to keep invaders from ever getting in the first place.
And these aren't just simple walls, they're super multi-layered. Your skin is the obvious one. It's a great physical shield, but it's also a chemical weapon. Your sweat makes it a really nasty place for bacteria to grow. Then on the inside, you've got sticky mucus that's like flypaper for microbes, and then tiny little hairs called cilia, or just a good cough. Physically throw them out. Even things like tears and saliva are part of the team, washing away germs. And get this, we're not even fighting alone. We have trillions of good bacteria living on and in us who are our allies, actively fighting off their more dangerous cousins for us.
Okay, but what happens when those walls are breached? You get a cut or you breathe in something nasty. That's when the fortress alarms start blaring and the immediate responders get mobilized. This is your innate immune system, the body's rapid reaction force.
And its number one job, its absolute prime directive, is this: to tell the difference between you and not you. It has to be able to look at any cell, any molecule, and instantly decide, is this friend or foe? Is this part of the body, or is this a dangerous intruder? And getting this right is absolutely fundamental, because if it messes up, it might ignore a real threat, or, just as bad, it could start attacking itself.
So how does it know the difference? Well, it looks for things called PAMPs. These are basically molecular signatures that just scream, "Invader!" because they're parts of microbes that you'd never ever find in your own healthy cells. It's a dead giveaway that something foreign is here.
Right, so think of it this way. The innate system doesn't need to know every single bad guy by name. It just needs to recognize their uniform. It sees that telltale molecular pattern, that PAMP, and it immediately knows, okay, that's an enemy. It's a brilliantly efficient system for just recognizing threats on a broad scale.
But wait, the system is even smarter than that. It doesn't just look for enemy uniforms. It also listens for cries for help from our own side. See, when our own cells get damaged and die in a messy, uncontrolled way, they basically spill their guts out, releasing molecules that should be safely tucked inside. And when the immune system sees those on the outside, it's a clear alarm signal. We call those DAMPs.
So yeah, a DAMP is basically a distress signal. It's a flare going up from our own troops. It tells the immune system, hey, something bad is happening over here. Our own tissues are being destroyed. This could be from an injury, sure, but it could also be a sign that some stealthy invader is doing damage without showing off its uniform.
So, once a threat is detected, either a PAMP or a DAMP, the troops move in. And they've all got different jobs. You've got the sentinels, the macrophages, kind of like guards on patrol, who are the first on the scene, literally eating any invaders they find. If the fight gets serious, they call in the neutrophils. These are the shock troops. They just flood the area to overwhelm the enemy. And then you have the dendritic cells. Think of them as battlefield messengers, gathering intel and racing back to headquarters to call in the special forces. But how do all these different cells coordinate their attack? A macrophage in your foot can't exactly send a text message to neutrophils floating around in your blood, right? Well, they communicate using this incredibly sophisticated chemical language, a system of molecular signals that orchestrates the whole defense. And this language is built on two key types of messages. First, you have cytokines. These are like battle commands. Attack, get stronger. They fire up other cells and get them ready for a fight. And then you have chemokines. These are more like GPS coordinates. They create a chemical breadcrumb trail that leads reinforcements directly to the heart of the infection. It's an amazing way to get your army exactly where it needs to be.
So the whole process follows this really clear four-step chain of command. It all starts with recognition. A sentinel cell spots that enemy uniform. That triggers activation, where the cell basically powers up to become a better killer. Then it releases messengers, blasting out those cytokines and chemokines. And finally, those signals recruit reinforcements, drawing a whole army of other cells to the fight. Simple, fast, and super effective.
But sometimes the first responders just aren't enough. Sometimes the invasion is too big, or the enemy is just too clever. When the innate system starts to get overwhelmed, those messengers, the dendritic cells, they call in the heavy hitters, the elite special forces of your immune system, the adaptive immune system. And these two systems are fundamentally different, almost like night and day. The innate system is all about speed. It's immediate, it's broad, it recognizes general threats, the enemy's uniform, but it's got no memory. The adaptive system? It's the opposite. It's slow to get going, taking a few days to build a response, but it is incredibly specific, creating custom-built weapons for one particular enemy. And most importantly, it remembers. It learns from every single fight so that it's always ready for round two.
The key to that amazing specificity is something called an antigen. So if a PAMP is the enemy's uniform, an antigen is a specific detail on that uniform, like a unique badge on their sleeve. The adaptive system's special forces, the T and B lymphocytes, create millions of unique receptors, each one designed to recognize a single specific antigen. They aren't just looking for invader, they're looking for influenza virus, strain H1N1. That specific. And because it remembers, the adaptive response gets stronger and faster every time it sees the same enemy. The first time you get sick with something, it takes days to fight it off. But the system creates memory cells, so the next time that same germ shows up, the response is massive, immediate, and totally overwhelming. And that right there, that is the entire principle behind how vaccines work. It's all about creating that memory. So, we have these two incredible systems. One is fast, broad, and hardwired. The other is slow, specific, and learns over time. But the real magic isn't in what they do separately. The real genius is how they work together, perfectly, to form one united front.
This is so cool, and it's so important. The adaptive system is incredibly powerful, which also makes it potentially dangerous. If it made a mistake, its custom weapons could accidentally target our own cells. So it needs a failsafe. And that failsafe is the innate system. The trusty innate system has to first confirm there's a real threat by spotting those PAMPs or DAMPs before it gives the adaptive system permission to launch its powerful targeted attack. And once that permission is granted, the adaptive system doesn't just take over, it reinforces the fight that's already happening. It deploys its elite troops and its super specialized weapons, like antibodies, and they supercharge the work that the innate cells were already doing. They work in perfect synergy. The innate response holds the line, while the adaptive response builds the perfect weapon to win the war for good. It's truly an incredible system of defense, a fortress of stunning complexity that keeps us safe from a hostile world. But this all leads to a really fascinating and, frankly, critical question. We've seen just how powerful this internal army is, so what happens when its recognition systems fail? What happens when this fortress, our greatest defender, gets confused and turns its weapons on us?